Hello again. Tonight, the topic is going to be smart scopes. These are I guess you could call them packaged telescopes. They come with a built-in camera, and you usually have to use a manufacturer-supplied app on your mobile device to control them and to view pictures from them. And I've seen two usage of a particular model of a Unistellar brand smart scope in the last week. And so I've come away with some analysis and opinions, as I'm often apt to do. I think the reason why people get them is they get infatuated with them. And then once they get them, they learn very quickly how they can become dissatisfied with what they thought they were going to get versus what they actually got. So what is a smart scope? Well, it's kind of a prepackaged telescope with tracking, imaging camera, and some software. It's kind of a fantasy solution. If you're a first-time telescope purchaser, you don't have the funds for buying, $10,000, $12,000 worth of big telescopes and tripods and computers and cameras and all various bits and pieces. So you think you're going to get the same thing because somebody else packaged it for you. And you know that it's a lot of work to learn how to get all this stuff so you get good results, and maybe packaging it will make it where that's easier, shallower learning curve in order to get good results. And if you are an amateur astronomer and you're into imaging, you realize how much effort it takes to do it, and the heavy weight of the setup equipment, and how long it took to get it to the point where you had good images. And maybe if you spend some money, there'll be a shortcut to doing this where it isn't so much as of an uplift every time you want to go out somewhere and get pretty pictures. So a smart scope or an intelligent scope is something that sets up quickly, sets up without a requirement for a finder scope. So you don't have to collimate your finder scope with the main scope. Sets up without star alignment requirement. So you don't have to do a 1 or a 2 or a 3-star alignment kind of thing. It'll go to anything. If you can think of it and it's in the database, it can go there. It can track anything, including comets and satellites. So you're really creating this fantasy of what you think it should be capable of, and then we'll get to what it's actually capable of. If you can point it at something and get it to track it, then you can take great pictures of it with minimal learning curve. It's kind of like you tell it to go somewhere, it goes somewhere, and it knows how to take pictures and align them and stack them, and then adjust the colors for the histogram and brightness, and it looks really cool. It's good image. You don't need to buy a separate camera for doing the fine tracking called guiding, and you don't need the extra software and cables to do it. And once you have the pretty picture in your telescope, you can share that picture with members of the public that might be at a public observing event. So some of what the reviewers and the packagers and the promoters are doing is they're giving you the ability to perceive that you're going to get all of this stuff, but they're never telling you up front, yeah, well, we can't quite do this and we can't quite do that, and you've got to have this to do that. And they don't tell you that, but people create a fantasy. So I've got the 3 different products that I've seen. The one at the bottom here is called the Dwarf. It's the least expensive one. It's sub $1,000, but a good chunk of change, close to $1,000. It's called the Dwarf. This is the Dwarf Model 2. Doesn't come with a tripod, no hand paddle, no finder scope. It knows where things are in the sky, obviously. Then you have the Unistellar, which is the one that I saw 2 of. And then you have what is known as the Vaonis. This one's just a tabletop, very small diameter, but has a lot of the same imaging and pointing and tracking capabilities. So these things are lightweight because you don't want to have to grow muscles or need assistance in order to set it up. It's small. It can collapse like the tripod folds up kind of thing, or it's just the head of the telescope, and it doesn't take up a lot of space. in your home. It fits in your small vehicle or trunk or even the inside of your car. So it's not a burden to carry it around or to set it up. It has very few separate parts. Unlikely you're going to misplace or forget to bring something. There's no hand controller, no cables. Everything is wireless, typically powered by a built-in lithium-ion battery that you charge with like a USB-C connector, so you can actually charge it from your laptop if you wanted to. Or you can charge it from a cell phone external charging battery. There's no optical accessories. There's no add-on camera. There's no eyepieces. There's no diagonal. There's no Barlow. There's no different filters for the eyepieces. And there's no finder scope. There's no secondary camera stuff. Well, actually, the Dwarf's kind of weird in that if you look at it closely, there are actually two cameras. There's the wide field camera and the close-up camera. And that allows them to get away with not having a finder because they're manufactured that way, so they're always collimated. But there's no guide camera. There's no, you don't have to have a laptop to do it. There's no extra cabling. It has rapid and easy setup. There's no requirement to tell the telescope where you're at or date and time zone and whether you're in daylight savings time or not. It kind of learns that typically from your mobile phone or your tablet. You don't have to collimate anything. A lot of times they'll presume that it's a refractor, a lens telescope, not a reflector, but they even do it with reflectors nowadays. But it's not your typical Newtonian. It's more like a Schmidt Newtonian. Doesn't have a secondary mirror. You don't have to do multiple star alignment. There's no requirement for you to know the night sky. You just use their app and select your target and it goes to it. It supposedly can move and track very precisely and repeatedly reliable. So it can slew to a target that is in the camera's field of view without needing a finder. Supposedly it can track for long periods of time without moving off target. And there's a way that they do that by looking at the bright spot in the image and touching things up should it move out of center. The presumption is it'll always take great pictures for you to personally enjoy without all that learning and effort. And it can take pictures that I can share with my friends or members of the public at some event. So that's the fantasized potential of it. But even the people that make these products, they don't realize that the consumer's fantasy goes even farther. They presume that I want to take pictures of anything, deep sky, large targets, small targets, very small targets. People would like to get a picture of the pillars of creation within the Eagle Nebula, but they don't realize how small a piece of sky that actually is. They'd like to be able to set it up in the late afternoon before it gets dark and they can't see, but that doesn't work that way because it does plate solving, so you can't really set it up and have it working until it's dark enough to see stars. People don't realize that if you take it out for the first time and you've never set it up before, you're going to need internet access to download their app. There's no like media to load it or a thumb drive or an SD card to load it from. You have to go get their app off their site. And the real downside at public events was if you happen to be a member of the public and just walk up and say, oh, that's a pretty picture. Can I get a copy of it? Well, there's no eyepiece for you to take your mobile phone and try and hold it up to the eyepiece like some people do. They'll tell you, oh, you go on the internet, you download this proprietary app that the vendor supplies, and then you load that, and then you open it, and then you find my telescope's Wi-Fi, and then you connect to it, and then you can say, go to the current image, and now you can download the image. And you lost them at, you need internet access. So I understand the cost of the various parts that make up these things. And I have to say, paying over $4,000 for a Unistellar is kind of like they see you coming. The Unistellar has, like a 4 megapixel camera. You can buy a 16 megapixel quantity one camera for about $30. The Unistellar uses 114 millimeter f4 Newtonian telescope that doesn't even have a secondary. The camera sits where the secondary is, so it's kind of like a Schmidt. That kind of telescope, including the mount, including a tripod, including a finder scope, list price quantity one, $150. So the innards of these things are very inexpensive for how much they're charging. I looked at the cameras, the actual chips within the cameras they're using, and these are like 1 or 2 generations older technology. The Sony chips are very popular for a variety of reasons, but the current generation Sony technology is called Starvis 2. A year ago, you would use Starvis 1, which is just Starvis. And then a year before that, you'd use the Exmor. And one of the cameras in one of these scopes is an Exmor. So the contemporary 16 megapixels, $30. The 2 megapixel Exmor has got to be way less than $30. And they're putting that in a telescope where you have no choice in the camera. And that particular telescope is $2,000. So yeah, they're keeping a lot of the margin by putting in last year's parts and small diameter, very wide field telescopes, so they're very forgiving. And the particular type of reflector they're using has a spherical mirror as opposed to a parabolic. And a spherical mirror is going to have optical distortions around the edge of the image. So the sweet spot of the image within the rectangular field of view of the imaging chip, actually, that's how they get away with some of the quality that they do with a much cheaper telescope is, well, we're just going to throw away the edges. So by having such a wide field of view and so few pixels in the camera, last year's technology, it's going to make it pretty much impossible for you to get a very small piece of something like the Pillars of Creation in a wide field view of the Eagle Nebula. And you just start looking at how they make these things up and how much they charge for them and what you don't get. So the Unistellar provides a very lightweight tripod. It's actually a camera tripod minus the head. So it's not just an inexpensive camera tripod. It's actually a cheaper tripod than that because it doesn't come with the pan tilt head on top. It's just flat. And you adjust the leg length in order to get the top of the telescope level. The Vaonis, they don't even bother giving you a real tripod. They give you this tabletop tripod, and that means you've got to put it on a table or a car body or something in order to sit somewhere with it. And the Dwarf, they don't make any pretenses at all. They just go, oh, you want to put this thing on a tripod or a tabletop tripod? Go get yourself one. That's how they get the price as low as they do with 2 cameras in it. So typically what you'd see in a more expensive telescope is a sturdy tripod, but that's for a heavier telescope. When you've got a much lighter weight telescope, you can get away with a more flimsy tripod. But the tripod doesn't have an internal brace on it. So you get a little wind, that tripod's going to get wiggly. So you have no spreader plate, which is also a convenient place where you could lay eyepieces, but you don't get eyepieces. So even further, I just started chipping away at all the stuff that, well, why does it cost $4,000 for a telescope when there's so much that you're not getting that you would get in $1,000 telescope, or you're not getting a hand paddle? Okay, that costs a lot of money in most telescopes because it's proprietary, there's software to be maintained, and the telescope hand paddle usually connects to your computer so you can run Stellarium and have it point the telescope. So you're not getting a hand paddle, you're not getting a computer interface, you're not getting eyepieces, you're not getting a spreader plate, You're not getting a finder scope. There's no built-in GPS. It's getting location, time, and date from your phone. And there's no battery-backed real-time clock. If it can always just reach out to your phone and get date and time, don't even have to have a place for a battery. So there's a lot of stuff that just isn't in these products that you would normally get in even a $700 telescope, but they want to charge you several $1,000s for them. This one, because I know people that have older mobile phones, because I just want a phone. I don't want any of that smart app stuff. I just want a phone. So they have a flip phone. And yes, Motorola still makes flip phones. So if you go up to somebody at one of these events and say, how do we get a copy of that picture? Well, you've got to go to the manufacturer's website over the internet and download an app. My phone doesn't do apps. Okay, well, the next thing you're going to have to do is go buy a new smartphone, because the telescope doesn't come with a hand controller. The only way you can control the telescope is by either having a tablet or a smartphone, and you run the app. So yeah, the cost of the telescope that was $4,000 just went up by, between $700 and $1,500, because you got to go out and buy a smartphone. So having the experience that I do in my career of working for a startup company and deciding, do we make this initial product offering out of metal, or do we make it out of plastic? Well, there's good and bad on both sides. If you're making it out of metal, like your typical telescope, those are very quick to start up because you're just bending metal. It's sheet metal, it gets bent. And there are fabrication processes for doing that, and they're very inexpensive. If it's plastic, and you want to do it for aesthetics, that smooth, shapely, aerodynamic kind of stuff, it's going to cost more because you need custom molds for that stuff. And it takes time to design the molds. You might not get them right the first time, so you have to spend more money to get, fixed molds, and it's slower to market. So if you're doing metal versus plastic, there are decisions to be made. The first decision is this thing going to be the best thing since sliced bread? We're going to sell 1 million of them. Okay, make it out of plastic because the per unit cost is going to be much less than if we make them out of metal. But if you're making them out of plastic, there's nowhere you can buy this part. You're going to have to go contract somebody to make the molds for you and custom injection mold them. If you go buy a metal-based telescope, there are companies in China that will build it for you, paint it in your colors, and put your name on the outside. And that's faster and cheaper to market. So depending upon, did you guess right? Is this the greatest thing since sliced bread? And you're going to sell several 100,000 of these a year? If you guessed right and did it in plastic, you've maximized your margin per unit sold. Took you a little longer to get it right to market, but you're making more money per unit sold. Now, you took out all those other pieces like eyepieces and a hand controller and all that other stuff, so you've really crashed your cost to produce the product. And still you're selling it for $4,000. Well, if you sell fewer of them than you thought, there are procedures for what's my MBA approach to dealing with. Hey, it costs us this much money to produce the first batch of them. They're not selling as well. What do we do? Well, depending upon how far off you are, you may just touch the discount because you got a heavy margin. Touch the discount a little bit, drop the price a little, and there you go. But in the case of these guys, they're selling it for more money. So I think they're selling at least as many as they anticipated selling because they've upped the price of them. If competition arrives on the scene and starts producing it in metal, oh, you got them covered because their margins are going to be smaller. If you have a competitor come on and they produce it in plastic, you've got enough margin in your high price that you could probably drop the price of it $500, and while they're still doing their startup costs, you'll have them for lunch. So they're more about the marketing than they are about satisfying specific customer expectations or fantasies. So I went in and I looked at the actual chips they were using, and I compared that against, well, what things in the sky, how big they are in the telescope's optical rig to see whether or not they would fit or not. And what I found fascinating was there's one company that uses this IMX 178 chip that is 3x1. It's an older, it's actually an automobile camera for safety purposes. And its field of view in arc minutes is 60 by 42, which, okay, what does that mean? Well, what it means is the 60 is fine. You'll be able to horizontally fit the full moon. Vertically being less than 50, you'll chop off the top and bottom of the moon. So you won't be able to get the full moon in your camera of your telescope. And there's no adjustment for that. It just can't. So you start to see, here's a 37 by 27. That's the initial Unistellar. Sounds good, but well, just scratch the moon off your list because you won't be able to get the full moon in it. But the next generation Unistellar, they said, okay, now you can get the width of the full moon, but you can't get the height of it. But then the Vaonis, which is a much smaller telescope field of view, but has a larger chip, they're good with getting the moon in. So I said, well, what if I chose my camera? What if I said, I want the latest Sony inexpensive camera, the IMX 585, which is still under $100 quantity one. I want to buy one of those, and I want to put it into one of these Newtonians. What would I get? 121 arc minutes by 121 arc minutes. I can see anything in the sky. Also, instead of being like a couple of megapixels, I'm 8 megapixels. My resolution goes way up. So you got to dig below what they're advertising and see, will it be able to see what I want to see? Are there enough pixels in the image in its field of view? And if I want to shoot something small, by the time I crop it down, are there enough pixels left for me to actually see what I want to see? But, you know, people that are just looking at the box or they're reading the promotion, they won't do the minutia and the nuance that I do. So I broke it down into a nice simple table. So if you have a wide field of view and you have a low pixel count, you have the most arc seconds per pixel. So that's the grainiest image. If you have a narrower field of view and you have a high pixel count, you'll get the fewest arc seconds per pixel. So your detail, your image resolution is better. So that's the balance you have to run, is how much of the sky can I see versus how many pixels do I have to go across that field of view? And then when I crop it down to what I actually want to get, how many pixels are left? And just remember, the moon is half a degree. So 30 arc minutes. This one I found almost comical. So they wanted to use even cheaper chips in some of these units. So they pick like 2-year-old imaging chips that are easily under $50 a copy. And the actual chip megapixels was 1.2 megapixels. But when they stored the file as 4 megapixels. So think of it as, if I've got very few rows of pixels and I want to make it look like I'm getting more pixels, I can take 2 rows of pixels and in math, spread them apart and actually synthesize by averaging what would be the row of pixels between these 2 rows. And then I'll put that in the graphical file. So I've got a chip that is 1.2 megapixels, but by the time I do horizontal and vertical interpolation, hey, I've got a 4 megapixel image. So they'll tout the camera as being 4 megapixels. But when you go to shoot something in detail, it gets kind of fuzzy because you're interpolating, you're averaging. So, you know, the image isn't what you think it will be. So when they tell you what the graphics file size is in megapixels, go back and look and see what chip they're using, because the guys saying 4 are actually using 1.2. The guys saying 7 are actually using 4. So when you go in there to zoom in on something small, it's going to get real fuzzy. And you may have heard the term binning in astrophotography. That's actually when we take 2 pixels and glue them together, or 4 pixels and glue them together, so we can take a faster exposure and it'll transfer quicker at lower resolution. But don't look to do that, because that's not going to get you the detail. That's actually going to remove detail. So binning. So how do you get it into focus? Oh, that's easy. You just don't change the focus. So if you've ever seen a camera that doesn't have a focusing adjustment, it's because it's fixed focus at infinity. So it's really good for shooting wide field stuff at distance, but it's very poor for portrait quality, for shooting a person's face up close. And that's because they have different fields of view and different depth of focus. So if I only shoot deep sky stuff that's, edge of our galaxy and beyond, I can come up with optics that it's fixed. I don't need to focus it. But if you also want to shoot like the Orion Nebula in our galaxy, or I want to shoot planets in the solar system or the moon, and it's deep sky fixed focus, the moon's going to come in quite fuzzy because it's out of focus. But if you don't have a focusing adjustment, it can't be focused. But the comical thing is, hey, that's another thing they got rid of that made it even cheaper is if you look at the earlier mobile phones, they actually had moving lens elements in them so they could do wide field and narrow field focusing, so they could shoot scenery or people's faces. And the latest technique is camera chips have gotten so cheap, the camera actually has 3 or 4, the phone actually has 3 or 4 cameras on them. They're all fixed focal length lenses, so no more moving lenses. So the cost of the mechanism for moving the lens was more expensive than just adding more camera chips and more fixed focus lenses. So that's what they did. If you looked at that dwarf, it has 2 cameras with different lenses. One is for wide field for doing your slewing, and the other one's for narrow field for doing your imaging. But let's say you want to take a picture of something, and it's something big like the Eagle Nebula. You can get a wide field view, and there's your Eagle Nebula. But what if you want the pillars of creation, which is a very small piece of it? Well, if you're doing your own optical telescope, not a smart scope, you go get yourself a Barlow or a zoom eyepiece, and now you can dynamically adjust the zooming. But if everything is fixed, how do you zoom? You zoom by, you take your image and you crop it down. You literally throw away the pixels on the outside. So by the time you crop it down to your region of interest, your ROI, within your FOV, your field of view, there's a lot fewer pixels there, and you interpolate it so it comes out fuzzy. So you can see my Eagle Nebula looks very nice and colorful and crisp, but then when you zoom in on the pillars of creation, it looks kind of faded because the dynamic range isn't that great. And it doesn't look sharp, it looks fuzzy. But even worse is, I want to take a picture of Jupiter. Now, obviously, this is not a Unistellar's picture of Jupiter. This is actually a Celestron with a multi-megapixel camera. So more pixels than they have in the Eagle Nebula image. And then right here, I don't want the shadow on the planet Jupiter. I actually want to see the moon that's transiting the planet. So I'm going to zoom way in. And by the time I discard all the pixels, I don't really have enough pixels left to actually get a detailed image of the moon transiting Jupiter. So they'll just tell you, it's good at deep sky. It's not so good at planets because planets are small and bright. So people that have owned inexpensive refractors have referred to this as their alignment is not really great. Well, if you have a very long tube refractor and then it's got a draw tube on the back for focusing, the flexure, it may be that the mount is precisely pointing the telescope in the right place, but by the time you put weight on the back, the tube and the draw tube actually bend down slightly. So you have to lift up the back end of the telescope to get it on target. So you have to overshoot your target in order to get the eyepiece pointing at the right place. Well, your Dob has the same thing, and that the tube is long and you're going to push on it. So it may be a little off, but you just think of that and you correct it yourself. You don't think, you don't obviously think, am I suffering flexure? Do I need a finder? But these smart scopes are so short in tube length, and the Vaonis especially, that the flexure from the motor tilt out to where the imaging is so short, and the tube is so stiff, they don't suffer from flexure. So you think of them as highly accurate when, no, they're just making use of a quirk of physics to not have flexure, which also lets them get away with no metal gears needed. Thank you very much. Plastic gears work just fine. So I think of these smart scopes as the engine that can't. It doesn't fulfill your expectations. It's got a wide field of view, and they're using things like a Schmidt camera type design. No secondary mirror. The costs are reduced. They have a fixed field of view and magnification. Some just kind of give up on the moon because it won't fit. If you zoom up on a tiny planet like Mars or Jupiter or Saturn, your digital magnification results in a loss of sharpness because you have to crop to get it. And you're using a less expensive camera, so it may not have the dynamic range to get you something bright like a Venus or a moon. But then again, if you're shooting a field of stars and you're doing it from a dark site, the stars may be too bright. When Les was using the Unistellar out at Big Cypress, there was a problem that the field of stars was too bright. There was too many stars in it, so plate solving was not working that well. And when they were using the Unistellar at Griffin Elementary, it was too early in the afternoon and the sky wasn't dark enough yet, so it couldn't find enough stars to do a plate align. Maybe they need to start offering substitutions and maybe, give you something to look through, because the Vaonis doesn't even have an eyepiece, even a camera eyepiece. You have no 2-inch capability, so people that have difficulty looking at things close up. You have no Barlow capability, so the magnification is what the magnification is. You have no filter selectivity, so if you want to say, look at a bright moon versus a dim moon, no adjustment there. And how would you do white light solar observing? You got to put a filter on the front, but that screws with how the software works. So what are the downsides to buying something that's prepackaged? Well, you don't get to pick what type of telescope it is. If you want a Schmidt or a Maksutov Cassegrain, sorry, you get basically a Newtonian. What if you want a different focal ratio for a different field of view? You get an f4, no f7 for you, certainly no f10 or above. What about the imaging camera? You get what they decided was cheap enough for them to put in. Whatever imaging software they're going to use is kind of what you're stuck with. What about the casual observer, the member of the public that just wants to see what you're seeing? You really shouldn't, require a proprietary app. And the battery. What if you're there for a number of hours and you want a longer lasting battery? The Unistellar, you can charge it, but you can't substitute in a bigger battery or an external gasoline generator. It is what it is. So that's the biggest downside, is you better know up front what you're buying, because if you don't know what you're buying, you're stuck with it once you bought it. So I think of it as an unfulfilled fantasy. And, you you have to either watch somebody struggling with one of these and learn what they can't do, or you wind up under somebody else's recommendation or promotion buying one. And then you learn that there's some things that are just not possible. Plate solving's great, but what if there's trees or buildings or mountainous terrain in the way? No plate solving for you. Wait until the stars that it can see are where you can see them. Maybe you can only do deep sky. So, dash your hopes on the rocks if you want to take pictures of planets or the moon. And I've seen this many times with astronomical equipment. Somebody will spend a lot of money on something thinking it's going to solve all their problems, and then they get it, and their experience is less than satisfactory. But they're not going to describe in a disdaining manner the product that they spent so much money to purchase, because that would be a loss of faith. That would be like shame on them for being gullible enough to do it. But maybe you can go back to whoever your friend was that recommended you buy this, or members of your astronomy group that voted to buy it, and complain to them and say, here's the shortcomings of what you convinced me to buy. For how much money? How do I make this better? Well, you might not be the one that wants to use that scope anymore, or you might kind of like do what Tim did. The circumstances of the environment that you're observing are such that I'll be back. Let me go get my iOptron and eyepieces. Or if somebody really convinced you to buy it because they bought one and they were claiming satisfaction when you bought it and then learned otherwise, you might want to go back to them and say, you convinced me to buy this, now what? And the resale value, because once the market starts learning the shortcomings of these, the resale value is going to fall through the floor. The thing you spent $4,000 on is rapidly going to be under $1,000. If you can find somebody willing to do it. So there are some things that they can, they can deal with. Just, mentally realign what you think of as what it's good for. You can shoot reasonably bright, but not too bright nebulas like the Orion Nebula. It's a great target. It'll actually get color out of the Orion Nebula, but it might take a good 10, 15 minutes to get a good image because it's stacking. You might want to put a troll in the audience. So if you're doing this to show off the great telescope that your organization bought, you might want to have somebody in the audience that's already familiar with the shortcomings and has already loaded the app on their phone. So, you're getting pictures and they can just look, see, this is what the picture looks like. And you can, convince people it's doing a great job by what they can see. And then if they say, how do I get a copy of that picture? Don't start down the path of, well, you just load the proprietary app off the internet, which we can't get from this dark site. Yeah. So you might want to not promote that all that much. Because somebody's going to walk up with, a 4-year-old iPhone, and you can install the app, but it's just not going to work well enough to be satisfying because it's too slow. So there's no magic pill that will fulfill people's personal or uncommunicated fantasies. It's just what you're promoting and what people perceive from it. And if you're really dissatisfied, you might try and get a refund as quickly as possible, because most of these have consumer grade warranties. And after 90 days, it's yours. There might be enough margin that they could accept it with a restocking fee, or you might find somebody else that would want to buy it under the same fantasy, but you're going to have to give them a good cut on the price. So you don't expect to sell it for the original value. And if you sell it for too low, they're going to go, why are you selling it so cheaply? But I'm maybe not the person to judge what you should spend money on and whether satisfaction is there or not. I own 5 astronomical mounts, 8 telescopes, and multiple astronomy cameras, both video and still, CCD and CMOS. So take my opinions with a grain of salt. But the manufacturers of these things could improve the situation. As the dwarf shows you, they could give you 2 fields of view because the cameras are cheap enough. Put 2 cameras in it. They could get cameras that have a slightly wider dynamic range so they can show you brighter and dimmer things. They could have the telescope operate as your basic web server, which is pretty cheap to come by. They don't have to write a lot of software that's available off the shelf. Maybe make it where casual observers that just want a picture of what you're shooting, just use a web browser. You don't need any special plugins or add-ons to do that. Make it where the public can just snatch the image as if it's a web page and then right-click and save it. So that way they don't have to deal with cloud services and it's up on the cloud. You got to download it from the cloud. Oh, you just have to install the app, get a login, then you can access the cloud. It's like, I just want the picture. And if you have ever watched people walk up to a telescope with their mobile phone thinking, I'm just going to hold my phone up to the eyepiece and shoot the world's greatest image. They're not always successful doing that. But if they can just browse to the web page of your telescope mount and get the picture and then save it, that's a fantasy that's easily fulfilled. And always make your telescope where it can be controlled by an external app like Stellarium for planetarium and something like eQuinox, which is free imaging software. And I had to do this because I've actually implemented a Raspberry Pi that is a web server that allows you to just see what the camera is seeing, and then you can download the image with no app. All smart devices come with a web browser. That's all you need is a basic web browser. You can present the picture. It's just raw HTML. You don't even need any fancy JavaScript to do it. And here's a snippet from the HTML. It uses what are known as meta elements in the head portion of the HTML, and you just describe it as refresh 8. So every 8 seconds, it will automatically refresh the picture. And people think about, oh, I need a different version of my app for an iPhone than for an Android, than for Windows, and I need a different version for mobile devices, than tablets, than laptops, and you don't need any of that. There are actually meta tags called viewport, and this is where the browser software interacts with the actual software running on the device, and it will dynamically adjust the width and the height of the image and make it automatically scalable, where they can do zoom ups and pinches and saves, and they can zoom way up and then pan it to see where they are in the image. And all that stuff is off-the-shelf web browser stuff, nothing fancy. And you can absolutely do that without requiring internet access. I found that there are kind of alternate approaches to doing this. Instead of buying a fully packaged telescope, you can actually buy kind of helper kits. There's one by StellarMate, there's another one by ZWO. These are modified Raspberry Pis that the StellarMate is an off-the-shelf Raspberry Pi with just custom software. The ZWO is actually, they took a Raspberry Pi design and built a different circuit board from it to make it more custom, which means it's going to cost more money. What I did was the thing at the bottom. I went to a company called Waveshare, and I bought off the shelf the box to put the computer in, a circuit board that has an Ethernet and 4 USB ports, and then a Raspberry Pi Zero W sitting on top, and put a cover on it. And that was the cheapest way to go. But that way I can plug everything into it. My cameras are networked, so I have a little LAN switch. I can plug 2 cameras in it. So I have a sky camera, and then I have the telescope camera. So I have wide and narrow field. And this also allows me, if I go to an event where somebody rolls up in a wheelchair and they can't get up to the eyepiece, I can hand them a tablet and say, here's what the telescope's currently looking at. So they don't even need to bring their own device. I can actually strap a little monitor on the leg of the tripod and connect it up by HDMI to the Raspberry Pi. So I have a always on, I have no user interface to it. It's just statically showing you what the telescope is looking at right now. And that's something you can't do with these prepackaged smart scopes. Okay, so although it may sound like that, I'm not a curmudgeon. I do actually believe in go-to telescopes and in imaging, and I am not adverse at all to improving telescope technology. I do agree with getting rid of the proprietary hand paddle, but removal of that should reduce the cost of the telescope, not increase it. And it should, because we now have open software, it should increase the capabilities of the telescope, not confine them. And I do agree with doing away with the finder scope, assuming that your camera and your the telescope don't suffer from flexure, then it should be more than reliable and repeatable enough that you could do away with that finder scope. And there are too many times I've seen people with inch and a quarter eyepieces, and people walk up with glasses and they can't quite see well. So I'm okay with doing away with the optical eyepieces, so long as the imaging camera produces a far more capable result, so you can do adjustable zooming and the camera chip has high dynamic range. Likely okay, but strictly speaking, it shouldn't be required for the telescope owner to use the proprietary app, because if it's open and you connect it to the internet when you're at home, you should be able to do over-the-air updates, just like a Tesla vehicle, to get improvements in your mount without having to buy, next year's mount. So when I look at like the version 2 versus the version 3, and you got to spend another $4,000, like that's the wrong approach. If it's just a software update that you've done to improve how well it works, download. Give me the ability to either via Wi-Fi or HDMI hook up an external display of my choosing size. So if I'm at a big event where there's a lot of people, maybe I can have, a big screen display. I've done that before at library and park events where I've got a large audience. I dim the display down to brightness 0, and it's still too bright at night. But that way I can have a 40-inch display and a crowd of people can see it. They don't have to be like looking on their phones or looking at a little tiny 12-inch display. And absolutely, it should not be required to have a proprietary app just to see and save the image. And you should not require internet access to just see and save the image. So, in conclusion, satisfying customers is something you have to learn how to do as a manufacturer. Eventually, not even brand names and high prices can sustain what I refer to as the con of high prices for reduced flexibility, because eventually people are going to learn. They're going to become aware. And as other companies enter the marketplace, your best held secrets are going to be out in the open as, you charged me how much for this thing? And, you're going to become last year's news. And I do think that smart scopes are the way. I bought Ioptron Cube smart scopes for years before people realized that maybe knowing date and time and location is helpful to getting your alignment, so you don't need a multiple star alignment. And if you can add an inertial management unit, an IMU, so you can detect tilt and rotation, even better. Now you don't need to, you got to point it north and level it, or point it south and level it, and then it can do it. Like, can it figure that out itself? Back when go-to telescopes were all the rage and expensive, the mainstream manual telescope operators just said, hey kid, go buy yourself a Dob and learn the sky. Well, as the reliability went up and the parts count went down and the total cost of ownership went down, nobody today who wanted a sophisticated telescope would ever say, I'm just going to buy a manual, thank you very much. If you want to do imaging, a go-to that does tracking, it's the only game in town. So the core of all these smart scopes is a go-to scope. It's just missing out on that GPS receiver and the inertial management unit, but they'll get there. And I've also found in my research that if not only the coordinates, date, time, tilt, orientation, if you have a environmental sensor where you can determine temperature, humidity, and barometric pressure, you can actually compensate for optical distortions by atmosphere. So when you're looking at something overhead, it's pretty much clear sky. You start getting to look at something low on the horizon, and you have to actually bend the telescope's view by a good portion of a degree because the atmosphere is bending what you're looking at the other direction. And they can do that. It's simply a matter of software, as the saying goes. So I think they'll improve over time. I think eventually smart telescopes will be like, every scope is a smart telescope nowadays, but they're going to have to really improve the smarts, maybe add a couple of devices, and absolutely not make them dependent upon proprietary apps or the internet. If you're a casual member of the public and go, can I get a picture of what you're taking a picture of? That's just got to be web basic stuff. And for those people that want to look at the details, I do have the brand and model names of the smart scopes. So if anybody says, hey, I've got a Unistellar, you can say, which model do you have? And is it the eVscope or the eQuinox? And that will clue you in as to, did you buy last year's model off of somebody who was trying to unload it? Or did you buy the $5,000? There's actually a $5,000 Unistellar that's the same 114 millimeter Newtonian. They just have a better camera in it. So, okay, if the camera was $30 and for under $100 you can buy a better camera, why did you bump the price from $4,000 to $5,000? Because they saw you coming. But the upstart is the Vaonis brand. They have the Stellina. They've already discontinued the Hyperia because it just didn't sell well enough, and the original Vespera. They're the one to look out for because right now they're kind of laughed at because they sit on a tabletop tripod. If they ever get the smarts to go, well, we've ditched the tabletop tripod, or you can buy the basic unit and then add on what kind of tripod do you want for it. Then that would bring them up to the same level as the Unistellar just by putting in a slightly better camera. And they'll actually get a better picture because they use a refractor rather than a reflector. So they've got a narrower field of view. So a lot of the problems with what a Unistellar can and can't take pictures of, the Vaonis solves, but is kind of thought of as a joke because it's on a tabletop tripod. And then for those people that want to see, well, what are these helper things? Because they've already got a telescope. You can look at the StellarMate and the ZWO. And then if you want to really get down to the basics, you can look at the Raspberry Pi. That's a hell of a lot of computer for very little money. And then how cheap the add-ons are to add the Ethernet and the USB and a little custom plastic box to put it all in.
Thank you. I was wondering about those different types of smart.
I would say don't just scratch below the surface. Get out your pick and dig deep. Because how they're promoting them, and I've seen videos promoting them, and down at the bottom of their presentation, it should say sponsored content because it definitely is.
Uh-huh.
If you see reviews on a website, always scroll all the way down to the bottom of the review. And if it says sponsored content, somebody paid them to give a rave review of that without exposing any of the shortcomings.
Monroe, they are not paying you, they are charging you.
Yeah, yeah. I feel
because
like I feel like I'm the Monroe of the telescope industry versus the Monroe of the automotive industry. That's his last name, my first name.
yeah,
But same thing. I'm too old to give a damn anymore, and I'm just going to say what I think.
yeah. Poking bubbles all over the internet.
Oh
That's
yeah, yeah. If you just Google smart scope, you're going to find there's really only three brands out there: the Unistellar, the Vaonis, and the Dwarf. And the one that's getting the most, like, it's so much cheaper, is it just as good? And the fact that they can do wide field and narrow field is really giving them an edge.
the things that you want to improve, like most of the stuff. Like in the case of, using internet-based programming to get the image, they will not do it because nowadays all they want is probably not even selling the telescope or anything, is getting the information. So
Yeah.
they will keep doing the app-based stuff because they are not just forcing the owner to download stuff, but the people who come near to the owner will download stuff, and that will
Yep.
be a source of information and also advertisement for their product. They are selling your information and they are using the information to sell more products, so they will
Yep.
not improve your idea. It's
Yep.
the opposite.
The other thing to consider is the companies, these new companies that are making this, like Unistellar and Vaonis and Dwarf, they don't have a lot of subject matter experts on everything that it takes to make up one of these smart scopes. When it comes time to, like, I need to get this pushed out to market as soon as possible because my MBA is on my back. Because we're burning through cash and we're a startup. So, okay, we got to do an app. About once a month, I get an email from somebody in some other country saying, we make really great apps. Just tell us what you want and we'll have it quickly and cheaply. So companies like Unistellar and Vaonis and Dwarf, they're not writing the app themselves. They're contracting with some app development company that churns these things out like butter. And all they're doing is rebadging somebody else's app. So they're not going to make the app any better because that would require them to go back and recontract and spend more money with the app developer that wasn't their people to begin with. That's why whenever you see an app that comes along with a product and you find a bug in it, the only way they fix that bug, well, you need to buy the next generation version of the product, and it comes with the upgraded app, because they're not going to spend the money, the cash, to go get the app upgraded when they're not selling you another product version to get revenue again.
Yeah, so
So,
it's like the app, it's not safe, and you cannot control the intentions of the app on your devices.
right. That's why you want it to be just a web browser, and the only thing it connects to is locally the telescope. And
They won't do
you
it
can even
because
turn
they
off
want
your
to make
internet
money.
access. There's no email, there's no login. You just go to the telescope, go to the default website on the telescope embedded web server, and up comes the page. And now you can, select what you want.
But they will not lose the chance to upload stuff on people's devices and get their information.
Well, the companies like Unistellar and Vaonis and Dwarf, they don't really care about that marketing money for that. That's why they're charging you $4,000 to $5,000 for this really cheap telescope. It's the app vendor that's a separate company that you never learn their name. They're the ones that want your email address so they can sell it. And if you think that I'm, blowing smoke or no, I never completed a project that would do that kind of stuff. Here, let me stop sharing of this, and then I will go back to sharing screen 2, and now I will open a web browser. Can you see it say Broward Astronomy there?
Yes.
Yes.
Okay. This is actually the solution that I took to Parkland twice that allowed the high school students to grab images off my telescope camera. So I've adjusted it obviously for Broward Astronomy. all I do is I connect to my Wi-Fi that's in the Raspberry Pi device. I put it out. It's called BA Telescope is the name of the Wi-Fi. I connect to it. I then go to the default page of that site. You can see the address is just the address there because I'm skipping the DNS and going to it directly. But there's a link there that says cameras. And if I click on the link, see how quickly that came up? That's just basic HTML, not even any JavaScript. That's how quickly it can come up. And I've got 2 cameras. They're not pointing at anything because they're indoors right now. But I've got my Broward Astronomy Skycam. It's a wide field of view. It's actually a fisheye lens I can put on a tripod and see the sky. Helen remembers this one from when we were in Nebraska and we were doing the solar eclipse. And
we
then,
use that one on the lunar eclipse
yeah,
on
I did the
the
same
park.
thing on the lunar eclipse. And then I've got the Broward Astronomy Scope Cam. That's my telescope cam. So I can click on that. You see how quickly that came up? There's the image. I actually embed into the image BA Scope Cam. And then this is the web page that you'll see. Obviously, it's not pointing at anything because it's indoors and the eyepiece cover is on. But down at the bottom, it tells you the camera you're looking at. It's from Broward Astronomy. You're doing this in Fort Lauderdale. And here's the current time of day. So it's got that information. But notice the 2 numbers to the right of it. This is the dynamic scaling of the image. So if I get out of full screen mode and I change this web browser page to be like that, and then I wait for it, about 8 seconds, see how it automatically scaled and updated the image? And now it's 722 by 397.
So it could be a phone, it could be a computer, it could be anything.
It can be a tablet. It can be a mobile phone. It can be a laptop. It can be low resolution, high resolution. You always send to the client web browser your maximum resolution image coming off the camera. And then you let the browser and whatever it's operating on, you let it automatically, dynamically scale the image. So I don't have to have, an Apple version and an Android version and a Windows version and a Linux version. I've got one version of the web page, and it does all this stuff in the client, not on my server.
Oh, and by the way, one of the times we did that, instead of people actually writing the address of the web page, Monroe made a QR code, and people just put the picture, and the camera find the QR code, the address, they click the picture, and they were taking the picture.
That's cool.
Yeah, I had to do that for earlier generation iPhones because earlier generation iPhones did not understand the DNS name reference of .local. .local says on this network that I'm connected to, and Apple didn't understand that. Even though that was part of the internet standard, they didn't support it because that might have been security threat or something. I don't know, but now they do. So yeah, having a QR code and the instructions on a little laminated letter size sheet, in landscape mode. And then I put grommets in it and I put little bungee cords to hold that on my tripod. So people can walk up and literally point their mobile phone at the QR code and it will take them to the site. So no proprietary app needed. Here, I'll show you what actually the inside of the web page looks like. And there it is. That's the entirety of the web page. So this is all the HTML that's there. It's your basic head, which has those meta tags for refresh and automatic scaling. And then it's got make the body of the display black so that the image stands out. And then center the image on whatever size window they're putting up there. Make the font silver so it stands out on the black background. And then the actual image. So the raw image that I'm shooting on a low resolution camera is 430 by 689. Weird, but that's to let the text show up at the bottom. And then I put in a little helper to say if I close this and I hover over the image, Watch, it'll rescale in 3, 2, 1. Come on, do it, do it, do it. There, see, automatically rescales. And if I just come on to this and click on the image, I can right click and do a open the image in a new tab. So now I've got just the picture at its natural resolution, and I can use the web browser to zoom in if I want to. But now I have a static image. So if I like the picture that is currently showing in the web browser, I can just save the image. It's mine now. It's not in the cloud. It's on my device. I can share that with my friends. But notice in the bottom corner it says, "Where'd you get the picture?" And eVscope cam. And if you look at the image, you can save it somewhere. And then you can look at the JPEG properties, and it'll tell you the same sort of stuff. But that's simple HTML, no JavaScript. All the fancy dynamic variable stuff is handled in the web server. So as somebody walking up and wanting a copy of what I'm currently looking at, piece of cake.
Oh, that's good.
Sometimes I actually finish projects.
Yeah, that was very cool. People loved this, especially like looking at the moon. Yeah, they loved it.
The high school kids at Parkland really loved it. They were over in a little clutch, like 20 of them, all looking at each other's phones and sharing the secret formula for how to get the image and save it. They were like 20 feet away from my telescope, and they were all getting a picture of what the telescope is currently seeing. Because the Wi-Fi, when there's no building obstructions, it's good to at least 50 to 100 feet out. Okay, that's it for tonight. Any comments, questions before I stop recording?
I think you said when you were out doing a presentation on a big screen,
Yep.
you couldn't get the screen dark enough?
Yep.
Is it possible you could just use window tint film on it?
Yes, I've actually done that on my own displays to darken them down. I've just cut out a sheet of window tint film, taped it on the top so I can flip it off when I want it brighter. The problem is when you're producing an image that has a black background and dim fuzzy stuff in it, putting a darkener on the front after you've set the brightness all the way to 0 means you're not going to see the dim stuff either. It's a good thought, but yeah, yep, you can tell. I've tried it. I learned by experience, even if it's like, whoops, let's not do that again.
Yeah, all you can do, like the most you can do, you can put film like those that cover lamps for parties. You can put red film, and that helps a little bit because it's red light.
If you've got a computer control display where it's how you use to control the telescope, and you're using it for your own like draft or preliminary image look, yeah, you can put what they call ruby lith, which is a plastic, over your computer display and dim it down so you're not blinding everybody in the neighborhood. You can do that on your control display, but on the display where people want to see what you're shooting, if you have a big display, really the only thing you can do is adjust the brightness down to 0 so that the black background sky is as black as the display can get it. So yeah, there's nuances is the best way to describe it. There are nuances that, as a company that does not have the forte, the subject matter expert, you need to go find the subject matter experts that, how do they get that to be that way? And either you pay a consultant a fixed duration, short-term contract to just give you some pointers, or you hire people that have worked in that business to be your brain trust to solve those kinds of problems, even when you didn't think you needed it up front. Any other comments before I start recording?
Yeah. I was thrilled when I first became aware that video cameras could be attached to telescopes. I thought that was a great development.
Oh, yeah.
There I go again. But there is something intimate and personal about looking through an eyepiece.
Yes, there is.
I prefer that.
That's why on my telescopes, if at all possible, I use a 2-inch eyepiece, because that allows people with vision issues, including glasses, to be able to see more easily through the telescope. If you give them an 1.25-inch eyepiece and you put like a 12 millimeter or smaller focal length eyepiece in the telescope, the aperture, the part you need to look through, when it's less than 7 millimeters, most people can't easily see through that. I find that if you buy a low light security camera with a pinhole lens, it's slightly cheaper than if you buy one with a glass lens. So if I'm going to take my low light, inexpensive security camera and I'm going to adapt it for use in a telescope, I'll buy the one with the pinhole lens, take the lens off, and then I'll put an adapter where the lens thread is, so it perfectly matches the lens thread of the security camera, and it blows it out to a C mount, which is in astronomy parlance, a T mount. So when you think of people taking their digital SLR camera and buying the T mount lens adapter, and then they can put it into the telescope, I can do the exact same thing with a security camera. I buy the little box, they're about $30. I buy a little box security camera that might be 2 megapixels. High dynamic range, very low light. And I take out the pinhole, I put in the T-mount adapter, and then I can screw that. And I can actually screw that onto the end of a Celestron zoom eyepiece. So I can adjust the zoom, adjust the focus, and then adjust the focus on the telescope. And now I have whatever size field of view I want. So if I want to shoot like the Orion Nebula, I can. If I want to go in and shoot Mars, I can. And it's all with the same camera.
And by the way, that solution could work for microscopes too.
Oh yeah. They do that with microscopes as well. When Sony came out with their Starvis 2, the cost of the camera came down, the high dynamic range, how bright and dim things can be in the same image, really improved dramatically. And they said, we just make the chip. They found other companies that would actually package the chip for different purposes, like security cameras, microscopes, telescopes, and the price point just is all over the place. So yeah, never say, oh, that's too cheap. How could I ever use that in my expensive use case? Well, the core of it is still the same cheap camera chip. And I'll actually be taking one of those camera chips already on a little box camera, a little, it's not a full body camera. It's just a little metal box that's bigger than the circuit board that the chip is on. And I take it out of that box and I mount a Peltier cooler chip on the back of it with a heat sink, so I can actually refrigerate the imaging chip to reduce the noise level to make it where I can take longer duration exposures with the off-the-shelf $30 security camera that otherwise you'd be paying $1,200 for a Peltier cooled low light telescope camera.
So the moral of the story is, rather than buying an expensive telescope or even a cheaper one, you can find images probably online somewhere.
Well, absolutely. And when somebody says, I want to go do astro imaging, the images are available on a variety of sites. You can actually get free time on a virtual telescope, like Virtual Telescope Project. You can see images they've already taken. You can buy time, which is pretty cheap, on a telescope and have it go wherever you want to go within reason and take images. Just realize that they're going to send you the image after the fact, kind of like professional astronomers do. Hey, go here, take an image, and then email me the image, or upload it to the cloud and I can download it from the cloud. But that's the way professionals do. As Helen and I know from experiencing reality, there are professional astronomers that might never have looked through an eyepiece of a telescope, because they work with giant telescopes and they're not allowed to get anywhere near them because they're very big and expensive and the technicians operate them. The astronomers that don't know how to operate them and maintain them aren't allowed to actually touch them. But you submit your request online from Chicago. The telescope is in Hawaii. It takes the pictures some days later, gets it just right, post-processes the image, and then the next morning you'll get an email. Here's your image, and then you got your image for your scientific project. It's good to have an impression of what you want to achieve, but if you don't tell people what you want to achieve, you have an unfulfilled, uncommunicated fantasy that you may be disappointed or dissatisfied if you go spend your hard-earned Benjamins to buy something that is overpriced to begin with. But if you really want to go out there and do it, you have access to the information I just gave you. If you have any questions, you have my email address. I will be glad to come along with my giant sharp pen. Is the best way to describe it. I think eventually, as I say, I'm not a curmudgeon. I think advancing the technology is definitely the way to go. I think eventually all amateur telescopes are going to be smart scopes. It's just inevitable. It's progression. But not just yet. They're too expensive, and the capabilities aren't fully there yet, and they have a lot of missed expectations. Okay, we'll stop recording now.